As he said, I'm Andrew Richardson. I'm a full stack engineer at Kaleido. I'm also a maintainer on Hyperledger FireFly. Probably can't see, but I'm representing the shirt here. You'll probably hear me plug that a few times during the session as well. But the topic today, we titled it Lessons Learned from Building Blockchain Consortia Apps, which is kind of a mouthful. So I want to start by just kind of setting the playing field for what exactly we're talking about. So a consortium, or a consortium, if you prefer the British, is just an association of business companies, right? It's companies that may be competitors, maybe partners, maybe a little bit of both, but they need to work together to do business. And this is maybe not the top thing that comes to mind when you think of blockchain headlines, but for me, it's one of the most exciting and interesting aspects of the blockchain landscape. And there are really a lot of use cases here in sort of business-to-business consortium flows to use blockchain to enable really new and innovative ways of exchanging data. So this is the landscape that we're talking about. And not only that, but Kaleido is a leader in this space and has a lot of experience in helping actually build consortia and host and run applications for consortia. Just a few of the projects that we've worked on with working enterprise consortia, RiskStream Collaborative in the insurance space between insurance providers, Synaptic in the healthcare space, Kaleido in trade settlement. These are all working groups of companies that are exchanging data and using blockchain to solve real problems in their industries. And I'm not going to actually show a demo of the Kaleido platform today, but just wanted to highlight that Nick has done many sessions on that. And if you're interested in building out a Web3 consortia, definitely, like he said, check out a trial at kaleido.io and check out some of the other videos on our channel to walk through, how you can set up a consortium, add members, invite them, and everyone have kind of control over their piece of the application. What I'm actually talking about today is trying to zoom out just a little bit and talk about, okay, not just at the sort of bottom level of exchanging data on a blockchain, but at a higher level, what does a Web3 consortium really look like? And what are all the pieces that go into it on top of the sort of Web3 blockchain technology that we like to talk about? So this is a slide I try to work into almost every presentation I give, but it shows the anatomy of a decentralized business network, right? We have a bunch of different members in a particular industry that need to exchange data with each other. Each of them has existing core systems. So on the left and the right, you can see core systems that have probably been around for years or decades and are well established and are running these businesses. But we want to find a new way to exchange data with each other. And so we have these decentralized architecture that each member can kind of run their own piece of infrastructure. And they're going to want at least two ways of exchanging data, right? They're going to want some data that's going to go privately directly from one member to another. And then, of course, the central piece that we all like to talk about, an immutable ledger or blockchain, where they can have public verifiable data and some other interesting constructs like digital assets, tokenization. So this is kind of the whole landscape that we're talking about. And I'm focusing today in these bubbles about the middleware. And you see the little FireFly logo there because it's going to help prove out a lot of these pieces quickly. And then on top of that, what does a decentralized application look like and how do you build one that works? So this is going to be a little bit of a personal journey of some of the lessons that I've learned being part of Kaleido, kind of journeying from being a Web 2 developer to a Web 3 developer and looking specifically at the consortium space and how you build a consortium and an application that works and makes it easier for businesses to exchange data. So without any further ado there, I'm going to jump into lessons that I've learned, and hopefully some of these will be helpful to you guys as well. Number one, solve a solvable problem. Number two, it's not all about the ledger. Number three, it's all about the ledger. Number four, put your things in order. And number five, build to last. So hopefully those are helpful lessons to you. Hopefully some of you have learned these lessons before. And of course, I'm going to dive into these in a little bit more detail throughout the talk here. So I'm planning to talk for maybe about 25 or 30 minutes about some of these and then give a demo to try and tie some of them together. And then we'll definitely close with some Q&A. But Nick, definitely jump in if you see any interesting questions to stop me along the way and dive deeper on some of these. So number one, solve a solvable problem, or, and to put it in other words, pick a question for which blockchain is the answer. This seems like kind of an obvious one, but it was not obvious to me coming into this space. But of course, blockchain, like any tech, it doesn't solve all problems, right? It solves some problems really well. And obviously, you have to start from a point of picking a problem that blockchain could solve. And this was kind of the first lesson that I learned coming into the consortium space, because it implies that you have an understanding of the businesses involved and what their problems might be. And it also implies that you have an understanding at some level of how blockchains work and what problems blockchains are good at solving, and that you can kind of find an intersection there, right? So it's an obvious thing, but it's also one of the hardest things, because if you don't start on the right foot, you're going to find yourself very quickly going down the wrong road. And I've been there, and I'm sure others on this call have been there, trying to fit blockchain into a problem that it really wasn't meant to solve. So I've highlighted some of the classic problems here. There's plenty more, but things like helping to verify trust and identity, helping to verify data traceability. You know, when data leaves one company, goes to another company, preserving traceability for the people that were involved in that flow. Reconciling different views of an object or event. This was particularly the focus of one of the RiskStream projects, where insurance companies might have different views of the same thing that happened. How do we figure out, without a central authority, that we're talking about the same event and that our individual participants have different views of that and need to get to a reconciled view of that event, right? On the flip side, if you've tried to solve some problems with disparate data and have ended with an overly centralized solution, blockchain's obviously a way to pull back and take more control over your data again. And of course, ordering. Blockchain is very good at giving you a determinate ordering of events. So just some of the problems that blockchain can solve, right? And starting from one of these is always a good way to kind of frame your planning of a consortium and what problems you're going to try and solve within that consortium. So to make it a little bit more concrete, maybe just some arbitrary problems here. Problem one is one that I've definitely tried to solve and have seen other people try to solve. And it says, okay, I have an existing business process. Why don't I just take that business process and convert it to a smart contract, put it on the blockchain, and then I'll get all these benefits that people are telling me I'll get from the blockchain. You can certainly do this, but this usually ends up being a very high effort endeavor. It takes a long time to do and to get other people in the industry to buy into it. You're going to end up with a lot of privacy concerns and questions that you have to answer there. And sometimes at the end of the road, you end up with something that's not all that different than what you began with, right? If you just are moving the logic, you may find that the problem is no easier to solve. On the other side here, I have another arbitrary problem, but saying, okay, we have a network of some sort of providers, and an individual participant in this network can only send 3 fizz per 24 hours, regardless of which provider he's coming after. Now, this is a very concrete problem. It's arbitrary, but you'll find analogs of this in banking and finance and insurance and all sorts of industries where we're all working together, but there's some sort of legal or overarching requirements that we all have to abide by. It's a defined pain point between members. There's a problem of how do we do identity resolution and how do we determine, that we're all talking about the same John. But once you solve that and find a way to agree on who we're talking about, there's actually very little data that's needed on chain to track this, right? So this is one that you can really see kind of a horizon for where you could put blockchain in very easily, supplement an existing process, and get immediate value and serve all things, right? So the first lesson that I kind of learned coming into this space was taking things like problem one and kind of shifting them over, making them look a little bit more like problem two, taking things that are sort of big and abstract and finding, okay, here's an actual singular point where blockchain could provide a real value. So that was lesson one. And once you have kind of done this, and again, this is probably sort of table stakes for anyone that has even tried to solve a problem with blockchain, you decide that you have a problem that can be solved by a blockchain ledger. The second lesson that I learned was it's not all about the ledger. And this is where I hear all the blockchain experts dropping from the call, I guess. But in reality, this is a big lesson to learn, and it's an important lesson. And it was kind of the second thing that I learned when working with consortiums, because it's easy to get really enthusiastic about the blockchain and say, okay, this is great. We've all agreed to work together. We're going to exchange our data on the blockchain. Let's put as much as possible into the chain. And it's important to take a step back, and I've seen this happen many times, to start thinking about putting a lot of data on chain and then say, wait, there's actually a lot of things we can't put on chain. The blockchain is not a replacement for existing data stores, right? This is not going to replace our entire back office system that we've built for decades. And of course, the blockchain has some inherent things that are good about it, but that can also be a liability, namely that it's public to all the members of the network. Anything you put on there can never be deleted, right? So you have to kind of step back, and before you start building everything on the blockchain, think about, okay, this is probably going to be a combination, right? It's not going to be all of my logic on the chain in isolation. I need to think about what data goes on chain, what data goes off chain, and how I'm going to bind those things together. And I would even say this is the thing that you need to consider second. After deciding a problem for your consortium, decide on the data before you decide on the ledger. Another thing that I've seen a few times is, getting married to, okay, we must use Ethereum or we must use Fabric or some other ledger technology before even deciding what the architecture of the application looks like. And that's another thing where I've seen it's kind of helpful to sort out the data before you sort out the tech. Another way to look at it is kind of pick what box you're going to put things in, right? Obviously, a lot of things are going to go on chain, or some things are going to go on chain, right? Data that's public to the network often is, I need to advertise my identity. I need to send my public signing key and assert that anything signed by this key is owned by me and you can trust it, assuming that most of these consortiums are backed by a private side chain and we're not operating anonymously on a mainnet, like you kind of think more of the sort of user-focused blockchain apps, right? So there's usually some sort of public notion of identity, some announcement of schemas that we're going to share, and then there's usually lots of proofs of off-chain pieces of data, but there's usually a lot of data that is going to have to fall into the right-hand box, right? If you look at these first two bullets, any data that can't be visible to all members of the network. If we're talking about a consortium, we're going to have a lot of data that's private to me or private to me and one other member, right? It's part of some dialogue that we're having, and the other members can't see it. I don't want to put that data directly on chain. And secondly, any data that's subject to deletion. If it's a regulatory or compliance requirement that I need to be able to purge this data and really, really purge it at some date in the future, I can't put it on chain. And you'll find when you're building a consortium application that these first two bullets are pretty big ones. And I'm sure anyone that's been in this space kind of finds that knocks out a large percentage of what you can actually put on the chain, and means that stuff has to stay in this sort of purple box on the right. As a follow-on to that, any business rules that operate on that data also kind of have to stay on the right. If I can't have the data on chain, I can't make the decisions on chain. I can put smart contracts and rules on chain that operate on the public pieces of the data. And there's usually some really good uses for that. And I'll talk about it in some of the future slides. And of course, whenever you can use things that are native on chain, like tokens, NFTs, using those to represent real world items can be really powerful. But you still have to think about how those interact and move back and forth. How do I tie these on-chain constructs to these off-chain constructs? How do I then interface all of that back into my existing software and databases? So this was the second lesson that I learned, kind of thinking, okay, I've decided on blockchain, but I need to now not only build a blockchain, but I need to build an integration between some on-chain pieces, some off-chain pieces, and thinking about which pieces of the solution go into which box and how they flow between them and how they interact and tie back and forth. Now, of course, moving on from that, the flip side is that it's actually all about the ledger. And this was kind of the third lesson to me. Once you reconcile the idea that some things are going to be on-chain and some things are going to be off-chain, you can realize that actually, as long as one or two or just a few things do go on-chain, you can start to solve real problems with the blockchain without having to put everything there. Some of the critical paths where blockchain can actually serve as a source of truth, tying back to the first slide, right? What problem are you trying to solve? Do you want to verify the sender of data? Do you want to verify the integrity of that data? Maybe with a hash to say that the data has not changed since it was sent. Track uniqueness, maybe with an NFT as a very powerful construct for saying that there's one unique thing in the world. tying data and ownership to that kind of token or construct, track and transfer of value, and again, ordering events. These are all things where you can plug into an existing process and use blockchain to solve an actual problem, right? So a simple recipe for a lot of consortia is, where's one point in my workflow? I don't want to replace my whole workflow, but where's a point in a workflow that happens between, my company and another company that I could defer one decision to the blockchain? And use the blockchain to be the source of truth for that decision, whether it's an integrity decision, a uniqueness or ownership decision. How can I supplement my workflow by moving one thing to the blockchain? And if you move one thing, then you can start to see other things that you can solve to. A picture of kind of what this looks like, again, putting FireFly in here because it's a really powerful way to kind of manage these data. They're going to take a lot of different forms. Look at one place where I'm sending data from company A to company B. It's probably going to be a combination of on and off chain data, because as I said, it's very rare in a business case where all of my data for a transaction can go onto my side chain for every member of my consortium to see. So assuming it's some combination of on and off chain data, I can use FireFly to pin those things together and be assured that the off-chain data is always going to be verifiable because of a hash that was put on-chain. Where's the point that I can send something from A to B and have B take an action on it? What is the piece of data? Is it a legal document? Is it some, initiation of a transaction? What is the piece of data that A can send and then the action that B can take? And you need both pieces, right? It can't be just A is going to put data out into the network. There has to be a reason for it, right? And some action that triggers. And if you plug in your existing core systems on both sides of this, then you can really start to build working flows that supplement, but don't replace your existing back office. And we've seen that can be really, really powerful in enabling people to move gradually onto a blockchain system and trust it, right? All right, one more lesson I'm going to talk about before I'm going to pause. I'm going to do a demo, and maybe we can even take some questions if there are any. The fourth lesson that I learned, I've called put your things in order. This is dealing with event-driven processing. So building blockchain applications is fundamentally different from building traditional applications, whether it's Web 2 or on-prem or any other type of applications that you've built before. And this was probably the most difficult lesson for me to learn, and probably one I'm still learning. But blockchains have a couple of unique characteristics. The first one is that blockchains are slow. They are designed to be slow, but they're designed to be reliable and to process transactions in a particular order. So the follow-on is that you're guaranteed that they will emit events in exactly the same order, even though they're operating in a decentralized way, right? This is obviously the core premise of blockchain, but it took me a while to kind of really understand the implications of this. And in building apps with different consortia, we've seen that there's a kind of a journey to figure out how do you map an existing business process into this sort of pattern. The follow-on to this sort of realization is that you can run decentralized apps, each in isolation, right? So each company runs their own copy of an app, not a single centralized app. And each of those apps needs to be driven by asynchronous events from the blockchain. So you think about the events going into the blockchain, the events coming out, and you can't treat your data any differently from anyone else's. So when I put local operations and I request changes to be made or operations to happen on data in the network, whatever the data is that I'm exchanging, I have to track the difference between things that my node is proposing and things that have been confirmed by the network. A diagram that I like to show in some form as well, thinking about two members here, A and B, that are, cooperating on a set of data through blockchain. They're linked together with blockchain nodes. A might be proposing some changes to that data. B might be proposing some changes to that data. Neither one of these can process their own changes in isolation, because they would end up with different results, right? If you do these changes in different order, you're not going to agree on the same data because you're operating in isolation. But if you put some proof of each of these items onto the blockchain, maybe you're putting a hash or some state related to each of these, and then you wait for the blockchain to confirm it, and you each run your processing in your own nodes only after the confirmation, then you can be guaranteed the ordering, the authorship, the data integrity, these things provided by middleware layers like FireFly. You kind of on the other end of the pipe are guaranteed to get the same series of confirmed events, right? So in this, I've shown, A puts in 1 and 2, B puts in 3. The way they were confirmed on the chain was 1, 3, 2. But even though the apps are operating in isolation, because they look to the chain for the order in which these things should be processed, they end up in exactly the same state. And this, again, was a very difficult lesson to kind of wrap my head around. But it's a really, really powerful and almost magical thing about building apps that are built on blockchain, because you can each own your copy of the app. And even though it's not directly talking to the other app, it ends up in the same state by running the same rules on the same events in the same way. And that's a really, really powerful concept. So I'm going to pause there because I've gone through and I've talked for a long time on those 4 lessons. Any questions there, Nick? Anything you want to add before I go on and show kind of a little bit of hands-on?
Nothing in the chat. I wonder, Andrew, if it might be worth going back to that very first slide where we highlighted a few of the use cases and just kind of bring some of these broad thoughts that you've been sharing kind of into reality with a few of these. Maybe I'll start with Synaptic, and I think I saw Eric on the call, who's part of Humana, but he may have dropped. But just to give you an idea of sort of how Synaptic is, utilizing these paradigms that Andrew has talked with. It's a collection of payers and providers, namely payers, in the healthcare insurance space. And, there's legal statutes that require them to every 90 days, every 3 months to pick up the phone, send a fax, send an email, and, do their due diligence to verify the integrity of these practitioner records. And now this consortium, a collection of, very, very much competitors, are now able to have what we like to refer to as co-opetition, where instead of every single one of these payers kind of redundantly performing the exact same task every 90 days, they now have a framework, they now have a system, and they now have a trust anchor where they can create a data marketplace, and they can, incentivize members to upload good data, and they can, allow other members to purchase data or to challenge the integrity of that data. So it's metamorphed into a very sophisticated, very elegant system. But the things that Andrew's alluding to of, how do we reference a practitioner record on the blockchain, and then how do we securely, encrypt it and transfer it, in return for, tokens or some fiat currency. This is really sort of the beating heart and the pattern that we've seen. And so they're a wonderful emblematic example of, the right way to build things, and sort of that wonderful compartmentalization of what goes on the blockchain, what stays off of the blockchain, and how do we move that data when a business process is triggered. So just a little color on that. And Andrew has worked really, really extensively across a whole slew of projects with the institutes and a lot of their labs and working groups. So I don't know if you just want to cherry pick one of those, Andrew, and just talk at a high level about a few of the problems that were solved there.
Yeah, happy to. And yeah, I've been really privileged to do multiple use cases with the Institute's RiskStream Collaborative, who are just a great example of a consortium that is working, that is getting input from different players in the insurance industry and bringing them together to say, what are the problems that we can solve? How can we exchange data better? How can we cut out things like long phone calls and kind of traditional methods of reconciling data? Probably my favorite use case that we've worked on there, I alluded to at least once during the call, is an application called RapidX that is designed for exchanging auto claims data, right? You have constantly this problem of auto claims, when there's a collision or other auto accident, and different insurance carriers have to get involved, right? And they all are going to have a report of that incident. And at some point, they're competitors, but they need to agree on, what were the details of that incident? When did it happen? Who were the parties involved? Who was liable? And how are we going to sort this out, figure out how payment is going to happen, et cetera, et cetera. And RapidX is a blockchain-backed application that allows this to happen, right? So the data about each incident from each carrier can be put into this application on their platform called Canopy that's backed by Kaleido. And that data is sent privately off chain from one insurance carrier to the other carrier, but is always pinned to the blockchain so that once it's recorded, you can always at any time later verify the hash of that data against the hash that was recorded on the blockchain, right? So you get this immutable proof on the blockchain of, what I said at a given time were the details of the event. And the events are always going to be processed in a definite order, right? So each carrier owns their infrastructure. They can integrate and we've pursued actual integrations with a lot of different claim software, but they're guaranteed that they're going to process all these events that are coming from the network in a guaranteed order and see, what the other carriers are saying until we arrive at a completely shared understanding of exactly what that event was. We record, who's liable and et cetera, et cetera. So it's a really powerful way to cut out what's usually just a sort of long system of phone calls and back and forth through emails or whatever, and put that into a dialogue that happens privately, but also with blockchain proofs to kind of track each step of the process.
Yeah, that's awesome. It looks like the chat and QA is heating up a bit, so we'll maybe take a couple questions and then let you do the demo. Hopefully crystallize a few of these points, and then we can circle back. So there's one from Jatin. Is it only the data that needs to be on the chain, or can you sort of extract the business logic as well? So trying to understand, what are the pieces that really need to be on chain, really need to be off chain. So I'll give a kind of a preamble to that and let Andrew add the majority of the color. A lot of it can be off of the blockchain, right? We see the blockchain kind of as the trust anchor, as a place to put, those indelible proofs and those hash pointers. But if we think of Andrew's example, right, when we're doing private messaging and sending something from company A to company B, the logic of what do I do with this asset, with this encrypted payload, with this JSON object, this PDF, et cetera, what do I do to it? What do I pull in from my back office system, and how do I react to it? That doesn't need to be in a smart contract. That can be codified into JavaScript, into Python, into C#, right? Sitting there directly with your application tier. Now, there are other circumstances, of course, where if we think about an escrowed smart contract, or we think about a sophisticated smart contract that's been approved to spend tokens, right? This gets a little bit more into on-chain logic right here. But the vast majority of the holistic business process, the if this then that statement, what do I do when I have a trigger or a function or an event coming out of the system? A whole lot of that can be handled off the blockchain in addition to that data storage. I don't know if you have any additional thoughts there, Andrew.
Yeah, no, it's a really good explanation, and just highlighting that specifically talking about consortia, it's kind of a unique beast, right? Because as a consortium, we've agreed that we want to work together, right? And we want to facilitate cooperation and decrease friction, right? So you can definitely run a lot of things off chain and just agree, okay, we're going to put these proofs on chain, and there's going to be this and this rules as to how we process them off chain as a follow-on. And if some member decided to modify those rules and execute them differently, they'd only be hurting themselves, right? So there's kind of this unique angle where when you're dealing with a public chain and an anonymous system and an untrusted landscape, you need to do a lot of things on chain to be sure that you're anchoring that trust. In a consortium, you kind of have a little more flexibility. It obviously depends on the use case, but it's very real that often a lot of those business rules can be off-chain, particularly if they're dealing with sensitive data. And you can figure out just enough pieces to put on-chain to give you that assurance of authenticity and verification without putting all the data and rules on-chain.
Yeah. All right. One final question, then we'll hop to the demo. Just to keep people engaged here. So, question just around sort of the cost justifications and the overall expenditure for running the blockchain. So, let me kind of decompose that question. So, you have the blockchain itself, right? We're talking about nodes. We're talking about a consensus algorithm. We're talking about a highly available disaster recoverable blockchain. That's kind of the bread and butter of Kaleido. That's what we're really, really good at in the enterprise space of running these different flavors of blockchain, centralized, decentralized, as kind of a delegated open RPC sidechain, or even providing you ingresses into public networks right there. If you take a look at this picture, though, that Andrew's showing, what you pretty quickly understand, and hopefully through his different lessons and different examples, the blockchain's a rather small piece of the overall stack. So when we start trying to, quantify the value of a system like Hyperledger or FireFly, we realize that it's providing us with a whole lot of that middleware and that engine and that broader functionality that we need for a full stack application. So the cost really becomes around things like, I need to integrate with an OIDC provider. I need to have elegant configurations for key management for my different tranches of end users. I need to deal with those different classes of public and private data. I need to ingest events and trigger processes in my own backend systems, etc. Then you need to host all of that stuff, right? So you need to have the blockchain hosted, you need to have this middleware layer hosted, then you need the actual application itself hosted, right? A Reactful front end, a Postgres database, Redis caches, Grafana, Prometheus dashboards, etc. right there. So that becomes kind of the broader cost in terms of just what are X number of pieces that I need for a full stack application. FireFly makes your life incredibly, incredibly easy by providing that engine, providing this really rich, elegant API surface. So that kind of answers the question of how do I build all of the things? How do I integrate all the things? And then the question becomes, all right, now I need to layer a veneer or front end on top of all this functionality that I'm doing on chain, that I'm doing off chain, and then I need to host it as well. So Kaleido's in a really, really awesome situation here to be able to help customers not only with that wonderful backend piece of the blockchain, but also to provide you with hosting of this middleware tier and then further hosting of the application tier as well. So it's just a lot of pieces in addition to blockchain when you're looking to just kind of decompose the broader stack and quantify the different costs as well. Great. Please keep firing the questions in. We won't ignore any. We'll get to them. But I want to give Andrew a chance to kind of show you guys some stuff in action right here. And I'm sure that will lead to some additional questions as well. So let's flip to the demo, Andrew. If that's
okay. For sure. One, I want to give one little preview that I held back the 5th lesson learned and am going to talk a little bit more about deployment and sort of road to production. So keep those questions in mind and we'll come back to them again. But yeah, I wanted to show a bit of a demo here. Can you see it if I maximize it like that?
Yeah, it looks great.
All right. So I've kind of contrived a simple solution here. What I've got is a consortium of companies, kind of generic companies, but they need to send things back and forth, right? Any company might need to ship something to another company, right? So it's kind of a classic shipping and delivery sort of consortium. Now, I have 2 companies that I've pulled up here, company 1 and company 2, that are participating in this consortium. Got logged out. I have a sort of sample back office here, right? So I've got a back office that's already in place. This is the piece that I was talking about that's sort of on the outskirts of that picture we were sharing, right? This is the thing that pre-exists. I've already got a tracking system for all my products that I can ship back and forth. I don't want to rebuild that whole system on the blockchain, right? I want to find a piece of that system that I can supplement. So this page here is just simulating that sample back office pre-existing system. It's kind of out of scope of the solution, but it's shown here so you can kind of understand how the blockchain piece and the piece in the bubble, that we're talking about interacts with my core system. What I want to do here is I want to send a shipment to another party in the system. My requirements are that I can describe the shipment to them, but the details of the shipment are going to be private so that no one else in the network knows exactly what I'm shipping. We're going to have a token economy. So we're going to leverage one really powerful thing about blockchain, and that you can have these fungible tokens where each shipment is going to cost a certain number of tokens. Now, you could imagine those might represent some real world value, or they might just be a Web3 construct to kind of promote a share and share alike economy, right? To say that I have to kind of ship things and receive things in order to maintain my balance of tokens, right? But there's going to be some exchange. I also am going to take this back office data and I want to assert that it's unique, and I want to also transfer ownership of that alongside the actual physical shipment. So when I ship something, I want a Web3 construct that uniquely identifies that shipment and also changes hands. And for that, I'm going to use an NFT. So each shipment is going to be mapped to an NFT. That NFT is going to change hands at the same time that the token payment changes hands. So I'm going to supplement my existing business flow of shipping one thing from a company to another company with all these blockchain proofs so that we have recorded on a ledger each step in that shipping flow. So I'm going to start out by entering a new flow. I'll just call this delivery 1, 2, 3. I'm going to say that the proposed destination is company 2. And the product ID is B1, which you'll see, again, I'm not preloading everything from my back office into this system. I'm just giving it an identifier, and it's actually going to go query my existing back office to pull that into this flow. Now, you can imagine this is a UI that maybe would be built out and would be used for this new system, or maybe it would be actually just an integration, and I would use my existing software to kind of make these calls in to start shipments and to process shipments, right? Now, I've started a new shipment here, and what's going to happen is that it's going to query into my back office. And this may take a short amount of time, may take a long amount of time, right? But this is that integration where there's something on-chain, there's something off-chain. And what's happened here is that the application has found the data in my back office, found product B1, and looked up, what does this actually represent? It's minted a new token, token 4, and this is an NFT, so it's guaranteed that now this shipment is number 4. There's never going to be another token 4 in this consortium, right? You can even look down at the blockchain and see, okay, this corresponds to an actual mint transaction on the blockchain. And then you can also see there's a piece of private data that was attached. When I minted this token, I put a URI that points to a piece of data. And this piece of data is actually leveraging a functionality of FireFly for storing and transferring private data. So this was looked up from my back office, again, just kind of some placeholder values here, but you can imagine any amount of data that would need to be attached to the shipment that I want to send to the proposed destination. This is not viewable to anyone else right now. This is attached to the NFT, and I can always verify by looking at the data hash that was recorded on the NFT mint. Here, this data hash here that was recorded on the blockchain, I can always verify that that private data maps to this hash, right? So even though the data is not public, anyone that receives the data can know which token it corresponds to. So that's one really powerful thing where I take an off-chain thing, map it to an on-chain thing. All right, if this all looks good, now the next step is to send this data over to company 2. All right, so I can see I've got my Web3 constructs in place. I'm going to send the data, and at this time, I'm also going to enter a price. And this is the number of tokens that company 2 is going to need to send back to me in order to complete the ship. This is going to trigger another blockchain transaction and a FireFly, what we call a pinned message. So this, I can click through here and see in the Hyperledger FireFly UI. We call it a pinned private message because the actual data, here is all the data about this, shipping flow, the product that's being sent, the NFT that maps to it, the events that have happened so far. It's exchanging this all directly over to company 2, but it's putting a hash of this data on the blockchain. So all the other members of the network can see the hash. They know something's happened, but they don't know who's engaged in that flow. They don't know what the data is. But me and company 2 can both look, because we have the private data, and reference it to the blockchain and know that it corresponds to this particular blockchain transaction. And I can actually look at the blockchain transaction as well and see here's the hash of that batch that was written to the blockchain. So each of these steps in the flow has an off-chain piece, an on-chain piece. Now, the next thing that's about to happen, we talked about, okay, what are the rules you can do on-chain? And so I included in this flow a digital settlement contract that incorporates the concept of escrow. So once both parties agree, we're going to initialize a digital escrow contract. I, as company 1, am going to transfer this NFT representing the shipment into escrow, and the receiver will have to transfer 100 of their tokens into escrow. And those things will both be held until we both either accept the smart contract and say, this shipment is complete, or until one of us rejects. So it's kind of leveraging the blockchain, for this sort of atomic operation to say we need to both approve for this thing to succeed. But we're not putting any of the actual private data about what's in the shipment. We're putting the token, and we're keeping the data attached to that token off-chain. So I'm going to go over to company 2 now. And since the data has been sent to them, I can now see it in their queue. So here I've received the data. I can now see token 4 on this side, and I have received that private data in my FireFly. So company 3 does not have this data. Any other member of the network does not. But I now have the data. I can verify, yes, this is the shipment I expected. All of that looks right. This price of 100 tokens seems correct. So I'm going to accept and say that, yes, I'll go ahead and authorize 100 tokens to be deposited and kind of move this flow along. That's going to send another message from me to company 1. Again, it's going to be an on-chain, off-chain kind of pinned thing. And it'll end up with a hash on the blockchain to say, yes, the shipment's been accepted. There we go. So that's moved along. Same thing. It's moved along on company 1, right? So we're both kind of tracking each step and can see each blockchain pinned message and the hash of the message that was sent to acknowledge it. And the very final step, we can see now also that the settlement has funded, right? The 100 tokens have been deposited. The NFT has been deposited. So the contract is ready to fulfill. The last thing I have to do is confirm when I actually receive the goods, right? So I say, yep, the off-chain real world delivery has happened. I verified it. There were 100 bananas in the crate. It matches what we agreed on, and I confirm this. And that's going to send one final message and also going to call approve on the smart contract. I can click through here and see that smart contract and see that it's been approved. And so once it's approved, that's going to immediately trigger the release of the funds. So this funds were released. The 100 tokens were released to company 1. The NFT, if I click here and look into the Hyperledger FireFly UI, I can see the journey of this NFT, right? It was minted here to track that shipment. It was transferred into escrow. This is the address of the escrow contract. And then when the escrow contract was fulfilled, it automatically transferred it out to the receiver. So I have this real world shipment that happened, and I'm tracking it with a Web3 construct. And I have this auditable, immutable record of how that shipment progressed on the blockchain, in FireFly, on-chain, off-chain, kind of marrying all these concepts together. Any questions there, Nick, that seem worth addressing before I kind of go to my sort of final lesson and close out the talk? We can definitely take more Q&A at the end as well.
There is one from Renato that I don't want to kind of neglect. I think we can maybe just bring that one in at the end, Andrew. It's more of a holistic macro question.
Okay.
Just to provide context to what Andrew showed you guys right there. He showed you a very emblematic example of how do we do these cross-company data flows right here. What was stubbed out essentially were those little microservices, those event listeners, those APIs that would go fully into the back office of a system right there. But you can see kind of how straightforward that would be, right? You have this full system, you have webhooks, WebSockets, where it's really easy to just be notified as soon as something happens, as soon as that piece of private data was sent for you. And now we just need to wait until in the real world that asset has been delivered, and then we're going to trigger an API call that can drive this application and subsequently drive transactions down on the blockchain. So that gets a little bit into sort of where Renato was going of just, kind of the order of magnitude for how do we collectively integrate all of these systems. It's those pieces on the edge, Renato, that really kind of, potentially can take the heaviest lift, because when we're thinking about a consortium model right here, yeah, that outer boundary that Andrew's showing you right there, when we're thinking about a consortium model, a lot of companies can have, different types of back office systems, different types of SaaS providers that they want to integrate with, et cetera. Or if we're dealing with common data sets, there can be, something of an uphill battle, I guess, in terms of synchronizing the way that, everyone needs to represent this data. We could be talking about oil and gas. We could be talking about insurance. We could be talking about supply chain. There needs to be a kind of common schema, a common way to identify these shared data and these shared payloads as well. We'll come back to that question. I'll let Andrew, speak more from a programming standpoint around some of those challenges. But I see it as the things on the edge as potentially being, kind of the heaviest or, quote unquote, the most bespoke lift in the stack. Yeah, absolutely. And yeah, I think that's a good transition into my final bullet here. So I want to share this last sort of lesson learned, and then maybe talk about things, like you said, at a more holistic level. But the final lesson learned, I've said build to last, right? Pick tools and designs that scale.
because a lot of times it's easy to think about Web3 as a one-time cost, but it's not a one-time cost, right? It's a different way of thinking about exchanging data, and it can be really, really powerful, but you have to build a system that can scale up, that can, in this case, bring on other members and build a consortium that works, right? It doesn't work as well in isolation. While there are problems you can solve by yourself with blockchain, you get really, really unique benefits when you can build a consortium and find ways to add people to that consortium and exchange data. Use open source. Obviously, I'll plug one more time, Hyperledger FireFly, built for exactly this purpose, right? Because we saw that this is such a big problem when you zoom out, right? It's not just the blockchain. There's all these integration pieces and middleware pieces and event synchronization pieces. And we've tried to make FireFly into a toolkit that just makes all of those 10 times easier. And as someone that has both built FireFly and then built consortium apps using FireFly, I have to say it makes things a lot easier. I'm also a big fan of hard hat. I've tried not to be too opinionated on this call about one particular ledger technology or another, but finding a development environment that allows you to do the blockchain pieces within them as frictionless a manner as possible is really powerful, right? And if you have gone through your data model and you've chosen what data is going to go on chain, what data is going to go off chain, and you find that you can't quite decide on which ledger is the best fit, definitely look at development environment as something to consider, and the cost of, what does it take to write the smart contracts? What does it take to test them and maintain them, right? That's definitely something that should factor in on, what is the open source ecosystem around it. Leverage skills that your team has. This is something that we've seen many times. You don't have to do everything in Solidity or a blockchain kind of specific language, right? These off-chain bits can be written in JavaScript, Go, Java, whatever is present in your company is always going to accelerate the building of a consortium if you can allow members to build their own integrations in the language of their choice and just agree on data formats, APIs that are standardized, you use sort of standard things like that. And on the flip side, minimize the dependency on niche skills. If you have to bring a consortium member on board and say that they need a fully scaled out team of blockchain developers, a fully scaled out team of cloud engineers, an IT team for support, it's going to be harder to build a working consortium if every member requires a large cost to operate. And just include all those costs when you're thinking about how a project could get to success. And the final bullet, choose a deployment that scales for different sizes of members. The other thing that I've really learned in kind of working hands-on with some of these consortia is that you're always going to have a couple of the big players that really want to own things and have their own IT department and have their own very specific security restrictions and want to own the blockchain nodes and own the data and really operate things at a granular level. But then you're often going to have other players that would prefer a more hands-off approach and would prefer something that's more hosted and managed for them. And you have to kind of think about that. And of course, an easy plug for Kaleido is that this is something that we love to enable and love to do, is to give members a way to build a consortium as a service and choose, exactly the control over their data and operations they want to have. Do you want to own it all? Do you want to operate it all? Do you want, some more managed infrastructure? And you can all talk together, right? You can all pick your own involvement and still have exactly the same availability of the network. So closing out there with one final comment. Of course, I've generalized a lot. I've talked a lot about things that I've learned, that I've worked on very specific use cases, but every consortium is unique. Every problem is unique. So pick what works for you, pick the blockchain that works for you, pick the data model that works for you. And of course, Kaleido would love to help. So we love talking about these things and finding the problems that are solvable and enabling businesses to build working consortia and exchange data. So we would love to have that conversation if you want to reach out to us. That is the end of my slides. And I do think we had some pending Q&A for the last 9 minutes. If we want to dive into anything. Yeah,
definitely. I wonder if you might go back 2 slides, Andrew. I just want to just extend on your final point there. So, when you come into this Web3 world, whether you're a newcomer, whether you're a seasoned veteran, keep your perspective on why you're here. You're here to solve a business problem, right? Going back to Andrew's first point, you're going to solve a problem. You've looked objectively at your current business processes. You've looked at kind of the state of play with intermediaries, third parties, your lack of transparency, lack of security, reliance on a centralized database. Focus on the quantifiable ROI that you're going to get out the other side through efficiencies or through heightened security. You're not going to make money by trying to host really hard things. So, really technical, really smart people are, all over this space in Web3, and they say, well, I stood up a local, Ethereum or Fabric orchestration, and I'm really good with those FireFly APIs. So I'll just host the entire blockchain right there. What we see when folks kind of go down that route is you tend to miss the forest from the trees, right? You get so enamored with, kind of the esoteric nature of the protocols and these P2P crypto primitives that you're not solving your business problem. You're spending all of your DevOps cycles and all of your different engineer cycles on doing something that's already built, right? And so, not to shamelessly plug Kaleido as well, but look for a company out there in the space that can take those things off of your plate, do those at an enterprise grade level, and allow you to focus on the thing that matters, which is A, the business logic, whether that's on the blockchain or off the blockchain, but B, really the experience that you can build on top of all of this stuff, right? It's that user-facing app or that organizational-facing app that's going to make an engineer's job, a whole lot easier, or, a line of business personnel a whole lot easier. So with Kaleido, we can just, sort of flip any switch that you want in terms of, hosting FireFly, hosting the blockchain nodes, even hosting your application and providing you with DevOps as a service so that you truly can keep your perspective on, how does my business work? How is my business going to evolve? And what are these new applications that we want to build on top of it? So I just wanted to kind of hammer that one home of like, not only solve a solvable problem, but like focus your attention and your money on the things that actually merit your attention and your money. Don't reinvent the wheel when the plumbing and the high grade hosting is already available. That can tend to actually be a sunken cost when you think, oh, if I host it myself and run it in my own cloud account or something, we know Kubernetes, et cetera, this will be cheaper. It turns out that that's kind of like Pandora's box waiting to be cracked open by either yourselves or another member of the consortium. So just wanted to add my 2 cents on that one, and we'll hop back to the questions here.
Yeah.
So one from Reagan, does the demo network represent a fabric network? So under the covers, what Andrew showed you was actually enterprise Ethereum. I imagine it was probably Quorum and IBFT, but it might have been Geth and proof of authority. Ethereum variants are really awesome around a couple things, around identities, with just the concept of addresses and, different ways you can very, elegantly secure those private keys, but also with digital assets. So specifically, some of these ERC standards like ERC 20, 721, 1155, 1400, et cetera, gives you this, sort of nice flexibility in terms of modeling fungible and non-fungible assets. So that was very much a Ethereum environment, sort of at the bottom of the stack, with a rich set of FireFly APIs kind of driving that on and off chain logic as well. Q&A. All right, I'll give this one to you, Andrew.
Right.
So sort of diving into the demo flow that you showed. So in the case of a shipment's only partially delivered, right, we have a mismatch of quantity or quality. How would we solve that issue, right? So where are we going to sort of deal with the logic of, I was expecting those 100 ripe bananas and I got 50 bananas and they were kind of rotting, right? How would we deal with that, and where would we put that logic?
Yeah, exactly. And that's where you start, again, start with a single operation, then you start to unpack the interesting questions and see how can blockchain help me out here. So you can define it in many different ways, right? Like I said, every problem's unique. It could be that I completely cancel the shipment and I reject it. And there's, a sort of a business mitigation process, right? Where I'm either going to go through existing channels for this case, or I have additional messages. I showed a very simple flow where there was a start, there was a send, there was an accept, there was a confirm, right? You could extend that to include, okay, but before the confirm, there's a review process and it goes back, right? And you can definitely, we've done cases like this where there's a special type of message for a sort of adjustment, and I would think in most cases, it's going to be that private data stays off chain, right? We don't want to advertise the fact that the shipment was bad, right? That's not good for anyone, right? But if there's a private message that can go, from the receiver back to the sender and say, hey, I need you to adjust this. Either I'm only going to put 50 tokens in because the shipment was only half there, or I need you to send me 50 more bananas, whatever it is, there's some message that goes privately back and is recorded on the ledger so that they see it, but no one else sees it, and then perhaps a new shipment or a new, you define how that works, right? But in most cases, you can kind of use the same building blocks of private messages, blockchain pinning, NFTs, token transfer, and kind of maybe you build out some more pieces of the digital settlement contract, so that you can add or subtract tokens after the fact based on particular rules, or again, maybe you cancel it and start a new one. There's lots of options there. And that's the conversation that you have with your consortium, when you get to this point, right? So it's kind of cool to go down that journey and think about all the different paths and how they play out.
Yeah, awesome. Thanks, Andrew. That's great. Couple really awesome questions from an anonymous attendee. Wish I could give you a shout out, but no worries. This really kind of hits on your first slide, Andrew, about why are we using blockchain in the first place, solve a solvable problem. But would you suggest any proven framework to find use cases for consortia, right? So trying to, decompose and distill down what's a common problem that a consortium needs to solve, right? Whether it's agreeing upon the integrity of a data or making sure that, everyone that needs access to data can confirm that it's been, put into a database in the exact same order, et cetera, right there. So it's really about, what type of business process flow, is involved in your consortia? How does it work today? And then, to my point that I made a few minutes ago, having that, honesty and that objectivity to, say, hey, there's room for efficiencies, or, we have this third party, or we have this intermediary that's causing friction, causing cost, or leading to, a lack of integrity in the data. So I think it's looking at the 10,000-foot view of how do things work currently? What are our problem statements, and what are ways to kind of, reframe those processes by using blockchain and using on and off chain data flows?
Yeah, it's a great question. And I guess there's no framework for identifying those that I know of. I mean, just from my personal experience, I threw a couple on here, right? Thinking about finding a gap that meets one of these. Okay, where's a gap where I don't necessarily know if I can trust a piece of data, or I have to hop through a lot of manual hoops to trust a piece of data, whether those are phone calls, wet signatures, sort of traditional processes. Can I replace one of those things with a blockchain-backed verification, right? That's always a good place to start. Many ways you could probably come to that, but definitely identifying a gap where blockchain could fill it is what I would always, say is the starting point.
Yeah, let me chuck a few out there. I know we're getting close.
Yeah, we can go rapid fire with the last few if we
go a few. All right, so just super high level, shoot off the cuff here. Are there any typical patterns around what's good proof and what's not a good proof, right? What's useful to put on the blockchain as a good indelible proof, and what's sort of an example of not a good proof? I'll give you an example, right? Don't leak too much data with your proof, for example, right? And so yes, we're going to hash everything that's sensitive, but don't get cavalier about saying, oh, I want to associate all of this additional metadata because at this point in time, I think it's innocuous, right? Remember, blockchains are indelible. Once you write it, it's there to stay. So be very conscious about, privacy regulations, right to be forgotten, GDPR, things like that, et cetera. So maybe not an example of what a useful proof is, but an example of a thought process as you're thinking about what to put on the blockchain. Question from Renato around, balancing number of transactions with gas costs. So great news. Kaleido is operating, today in the world of, sovereign, private, permissioned Ethereum blockchain. So when we're using Geth and Quorum and Polygon Edge and Besu, you get to use different algorithms, not proof of stake, but digital signature algorithms. So the gas cost, the gas price always defaults to zero. So there really isn't even the concept of pay to play or pay to have execution inside of this system. Now you can weave in token economics similar to how, for example, Synaptic has done it in their use case, where we can have dependencies on, you can't call this function until you're able to send X number of tokens either to a smart contract or to another address inside of the system right there. But long story short, you can hammer a private Ethereum blockchain with hundreds, thousands, millions of transactions, and your only sort of underlying liability is going to be just how much storage you accrue, which is really dependent on how much memory your smart contracts exerting. So I'd love to talk more about sort of the flavors of blockchain you're looking at and sort of any use cases you guys are exploring, Renato.
And I'll put one more plug out there for FireFly. Another thing that was a big thought process going into FireFly is even on a zero gas network, it can be slow to put a lot of transactions concurrently, and so it's got very highly optimized batching in there to put messages into batches and to get very, very high throughput and kind of leverage the blockchain to proofs, but also not wait 10-30 seconds for every single message to go through.
Yeah, that's awesome. I'm going to throw a few, I know we didn't get to every single question, so apologies, guys. Just if you have any follow-ups, you can contact support@kaleido.io. I monitor that. If you have commercial-facing questions, you can contact sales@kaleido.io. If you want to have a one-on-one and go through architecture or sort of technical componentry, you can always ping me directly. And then just one more plug for Kaleido. It's free, right? So like there is no paywall barrier. Just go to Kaleido.io, sign up for a free account. We have example token smart contracts, example other flavors of Solidity. You can go to Open Zeppelin and pull your own examples out from the wild, and figure out how easy these APIs are, right? And once you trust that the guts and sort of that underlying engine and middleware is not rocket science and it works at that enterprise grade level that you need it, then you can just sort of keep your perspective on the process and the problem you want to solve, allow you to focus on smart contracts, but really on that on and off chain sort of process flow. So please don't be shy. If there's anything we can do to help, just give us a ping at one of those URLs that I shared right there. This is recorded. We'll send it out in about 24 hours. It's also on YouTube. So I think that's it for housekeeping. I just want to say a huge thanks to Andrew for carving out some time in the middle of his day as he's working on all these projects to share some of the lessons that he learned as a non-blockchain engineer coming into this space and now as a subject matter expert. So huge thanks to Andrew and huge thanks to all the attendees and for all the great questions as well.
Yeah, thanks, Nick. And thanks everyone for coming and listening and asking good questions.